CITS section 4.2 is the beginning of exponential functions and applications. Now, when I say the beginning, in this chapter we're working on does a lot with exponential functions and logarithms. This is just kind of the beginning to get everything started. Now, first of all, we'll just give the definition. I know we've all seen exponential functions before, depending on how well we remember it. The definition of an exponential function is when f of x equals b to the x. B is a constant. Okay, by that I'm saying b is a number like 0, or it can't be 0, I'm sorry, like 2, 3, 4, or 5. Now, b has to be positive. Okay, it can't be negative. B cannot be 1, because if I raise 1 to any power, I just get 1. So then, therefore, it's not an exponential function. Okay, and x is any real number. Okay, so what I'm looking at here is I have two different types of exponential functions. The first one is called the increasing exponential function. Exponential functions are defined basically by what that value of b is. If it's increasing, it's the same function as the exponential, except for now b has to be bigger than 1. The reason for that is because if b is bigger than 1, when I take that to the power of squared, cubed, to the third, to the fourth, fifth, sixth, whatever, it goes up. Okay, it's going to increase faster without bound. So, again, the exponential function is increasing when b is greater than 1. The domain of the function, we'll have the graph over here. A general exponential function will go through the point 0, 1. Okay? It's going to have a horizontal asymptote at y equals 0. It's going to be increasing across the whole domain. So it's going to be going up as I go right to left. Again, increasing and decreasing depends on if you're going right to left. And then we have a domain. Well, the domain is all the x values. Since I have an arrow over here, it's going to go to infinity to the left. As it goes up, it goes to infinity to the right. So the domain is from negative infinity to positive infinity. The range is from 0 to infinity. Because of this asymptote, I cannot, I will go to that 0 as I go out to infinity. Okay? So now, and because this is never negative, we can't go below it. There is one special type of increasing function. It's e to the x, and that's e where e is the exponential. Okay? And if we recall, the value of e is about 2.71, and it's found by taking 1 plus 1 over n. Okay, it's a sequence to the nth. Okay, and as n increases without bound, it's adding all of these up, and we end up with that value. Not something you really need to know until we get further on. When we get into sequences and series later in the book, we'll revisit that. Okay. Now, I also have a decreasing exponential function. Starts with the same general function, f of x is b to the x, but now b is a fraction. Okay, a fraction between 0 and 1. So when b is 1/3, well, when 1/3 is taken to a power, when it's squared, it's 1/9. When it's cubed, it's 1/27, so on and so forth. So as I go right, it's going to keep getting closer and closer to 0. Okay, so I have this decreasing function. It's decreasing across the whole domain. So as I go right to left, it's always going down. Sorry, I'm talking with my hands here as I look at the monitor. So the domain, again, is negative infinity to positive infinity. The range always goes low to high. So even though it's decreasing, and there's the bell, even though it's decreasing, I'm going to go from 0 to infinity because I always go from low to high. Okay? Now, these values can be shifted around. At this point in the book, they really don't ask you to. Back in the advanced algebra book, we wrote our functions, I should write function notation, as a times b to the x minus h plus k. Okay? And so all that's changing now is that I'm sliding this point 0, 1 slides to h and k. Okay, so if I'm going to graph something like, let's go 2 to the x minus 1 plus 4. Well, if I look at the graph of 2 to the x, it would look like this. All I would do now is I would slide it left 1. So this point comes over left 1, it's right there, and up 4. So now this point's up 4. The horizontal asymptote then would also go up 4, and the graph would look like this. Okay? So it's just sliding the graph around, just like we've done so far in this chapter, or in the previous chapters in this book. Now, I do have a couple of examples here. First one's pretty straightforward. Just wants to make sure we can evaluate it so we can look at the values. Now, before we start, h of x is 4/5 to the x. Before I even do anything with this, I know that it's a decreasing function. I know that its domain is negative infinity to positive infinity. I know that its range, being there's no sliding of it, goes from, square bracket there, 0 to infinity. Okay, just because of the type of function it is. Now, if I went back to this one, I know my domain is still negative infinity to positive infinity, but my range is going to change because my asymptote went up from 0 up to 4. So now that's going to go from 4 to infinity. Okay, see how that makes that little change there when I slide it? Now, it just wants us to find the values. The value in x is negative 3 and 4. So h of negative 3 just means I take 4/5 to the negative 3. Well, let's evaluate that without a calculator. That negative, first of all, tells me I can flip it over. And now I just cube each of them. 5 cubed over 4 cubed, which is 125 over 64. Okay, if I want to find h of 4, that's just 4/5 to the 4th, which is 4 to the 4th over 5 to the 4th. Ooh, 4 to the 4th is what? I want to say 256. I know you guys are going to check that on me. And 5 to the 4th, I believe, is 625. Just to make sure we're right so I don't give any cheap extra points away. 4 to the 4th, 256, 5 to the 4th. There we go. All right, my brain's working today. Now, number 22. Sketch the graph of f of x equals 4 to the x. Now, when you sketch a graph, I want you to give me a couple of points. But we know that it's an increasing function. Because 4 is greater than 1, right? B is greater than 1, so it has to be increasing. If x is 0, it's going to cross right there at 0, 1. We know that as it goes left, it's going to get close to the x-axis. As it goes right, it's going to go up. So just for the fun of it, let's get a couple more points off of this. The easy way is get different values of x. When x is negative 1, so x is back here, I get 4 to the negative 1, which is 1/4. So at negative 1, I'm at 1/4. I could get more on this side, but we know the way the graph goes, so I really don't need to. If x equals 1, then y equals 4, right? So at 1, I should be up at 4. So if I'm going to graph that, I probably should have gone up a little bit more. So it's going up pretty quick. Okay? So just give me a couple 3 points on there. I shouldn't say a couple 3. Give me 3 points on there. And then, just make a quick sketch of a graph. Do the same thing with the next one. Here, let's do this. We'll make a XY table. Make it easy to do. Since it's just a straight function with no a value and no sliding on it again, I know it's going to cross at 0. Anything to the 0 is 1. I know it's going to be a decreasing function with a domain that's going to go from negative infinity to positive infinity, and a range, since it hasn't slid anywhere, that goes from 0 to infinity. So if I let x equal positive 1, well, that's going to be 2/3 to the 1. So at 1, I'm at 2/3. I'm right about there. At negative 1, I flip that over, and I get 3/2. So at negative 1, 3/2, which is 1.5. And I can make my graph. Gonna come close there and go up fairly quickly. And that's all I'm really looking for with a quick graph. I'd like you to give me the domain and range, just so you get more practice in that, and then some points to make the graph, increasing or decreasing. Okay, so pretty straightforward on this section. It's more of just an introductory section to those exponents, and we'll get into more as we go along.